This video is going to cover the first lesson in our unit on systems of equations. It's learning target 1. We're going to solve systems of equations using what are called the substitution and elimination method. So what we're looking at right now, this y equals x plus 4 and 2x plus y equals negative 2. This is a system of equations. It is two equations that have two variables. Do know that all equations that have both an x and a y can of course be graphed. So I would like to take a look at what the graphs of these two equations look like so we can start to understand what it means to solve a system and what the answers to a system really do mean. Here are the two equations graphed. The y equals x plus 4 is the red graph, and the 2x plus y equals negative 2 is the blue graph. Notice that there is a spot where the graphs intersect. This coordinate is an x and a y that works perfectly for both sets of equations. If I were to substitute this point into both, let's find out what happens. 2 equals negative 2 plus 4. This ends up with an equation that says 2 equals 2, which is a true statement. Plug it into the second equation of our system. 2 times negative 2 plus 2 equals 2. This also equals and negative 2. So this is a true statement as well. The x and the y work when you plug them into both systems. The point at which the two graphs intersect is called the solution. The intersection point of the two graphs is the x and the y that works when you plug them into both. Now, it would be kind of a big pain in the butt to have to try to graph every single set of equations. So we have a couple of other methods. We have the substitution method to begin with. I'm going to show you how to use the substitution method with this system of equations. The second equation has a y, and this y is equal to our 8x minus 11. There is the same y next to the 3 in the first system. So what I'm going to do is I'm going to plug all this information into that spot, since that y is equal to what the y in the second equation equals. With it plugged in, the first equation looks like 3x minus 3 times 8x minus 11 equals negative 9. What I've achieved is an equation with only one variable, an equation I can solve. Let's start to solve this. Distribute the 3, and I get 24x plus 33 equals negative 9. Negative 21x by combining like terms, minus 33 on both sides, which is negative 42, and divide by negative 21, and I end up with an x of 2. This is the first half of my solution. The second half of my solution would be to take this x and plug it into the x of either the first equation or the second equation. I'm going to go ahead and plug it into the equation that starts with y equals. So there's the 2 plugged into the x next to the 8. 8 times 2 is 16, and 16 minus 11 is 5. So my answer to this problem is 2, 5. Elimination method works a little bit different. Elimination method is a way of adding or subtracting two equations together. What we're looking for is one of the sets of variables needs to create 0, or in other words, needs to be eliminated. Watch what happens when I add these two equations together. Negative 2x plus 2x equals 0. These variables are eliminated. Positive 8y plus positive 2y is positive 10y, and 14 plus 6 equals 20. Divide both sides by 10 and I get a y of 2. So there is the first half of my solution. Like I have my y, I need to now find my x. I can now plug in that 2 into either of the y's of the two equations. I'm going to choose to plug it into the second one, but it wouldn't matter. 2x plus 2, plug in the 2 for the y I got, equals 6. 2x plus 4 equals 6. Take away 4 on both sides. 2x equals 2. Divide by 2 on both sides, and x equals 1. I have the second half to my solution. So my answer is 1, 2, making sure I have this in the correct order, x's and then y's. Let's take a look at this problem. In this problem, I notice that neither of the sets of x's or y's, if I were to try to add them together, would make 0. Positive 3 plus positive 9 is not 0, and negative 2 plus positive 3 is also not 0. What I can do is I can get this ready to be solved. The way I do that is I multiply one or both of the equations to transform one set of coefficients into the same number. I can achieve this by multiplying the first equation by a 3. This will turn the 3x into a 9x so that I can continue. Now my first equation will say 9x minus 6y equals 15. And my bottom equation will say 9x plus 3y equals 33. Now I'm ready to combine my two equations. If I were to add these equations, 9x plus 9x doesn't make 0. So I'm going to choose this time to subtract my equations. 9x minus 9x will make 0. Negative 6 minus positive 3 equals negative 9, y. 15 minus 33 is negative 18. Divide by negative y, and I get positive 2. There is the first half of my answer. Take that negative 2 and plug it into either of the two original equations' y locations. I'm going to choose to do the first one. 3x minus 2, plug in the 2 I found, equals 5. 3x minus 4 equals 5. I'm going to add 4 to both sides, and I get 9. Divide by 3 on both sides, and I get 3. There's the second half to my solution. So my answer is 3, 2. Let's consider this equation. I'm not going to solve it completely, but I just want to show you the differences between doing substitution on this problem and doing elimination on this problem. If I were to do substitution on this problem, this is what it would look like. I would first have to turn one of the equations into a y equals equation. I did that to the first equation by minusing 2x on both sides. Now that I know what y equals, I plug it in and I continue to solve until I get an x of 5. Then I can plug the 5 back into one of the first problems and get my y and have my answer. Now let's take a look at what this same problem looks like if it was doing elimination. Since I have a positive y and a negative y, adding the two equations together will automatically eliminate the y's, giving me 5x equals 25, which only has one more step to 5. After that, I still plug in that 5 into the first equation, just like I did in the substitution strategy. But notice how much shorter the elimination method is, and how less work it is. Sometimes equations are set up to be better solved by one method or another. So how do you judge which method is going to be easier or shorter? Here are some hints and strategies. Substitution works best when a variable is already solved for. What I mean by solved for is I mean that One of the equations already has just x equals or just y equals. Another situation is if you notice that there is a variable with no coefficient, like this y. This problem would be very easy to turn into y equals 20 minus 7x. Then I'm ready to substitute. Elimination method works better when you try to add or subtract two equations together and you know that one of the sets of variables will cancel out, make 0. This problem has a negative 5y and a positive 5y. I know if I add those together, they're going to eliminate right off the bat. This system is easier to solve with elimination than substitution. Okay, if you have any questions, make sure that you're using our text message service. Don't forget to answer the questions right after the notes. If you don't hit the submit button, I don't have record of you watching the video, so make sure you do that.